video, we're going to look at the way acceleration affects the position and the velocity of an object. So we're going to back up. We'll start off with a real quick review. First of all, when we talk about the object, we're talking about something in a physics problem, a car, a rocket, a runner, or whatever. And so we have that object. And then the first concept is the position of that object. So the position can change, and when the position changes, we call that motion. So if something moves from point A to point B, or as we like to say in physics, initial position to final position, the displacement is the distance between those 2 points. So we have displacement, then we have the rate at which something moves. So we have the change in position is motion. Okay? The rate that position changes, is velocity. Okay? So that's we've worked up to that. And we came up with an equation ultimately that said that final distance is equal to the initial distance plus the change in distance, which we represented as delta D. And we went on and we said that delta D is equivalent to the velocity, the rate at which something is changing, times the amount of time that it changes. So the change in position is Vt. So we can plug this into our original equation. So the final distance an object has is where it was to start with, and how fast it moved, and how long it moved. Okay? So to get started with acceleration, we need to understand this concept, that the rate that position changes is called velocity. So that's the rate of motion. The rate that position changes is velocity. The rate that velocity changes, as in a car accelerated from the red light, the rate that velocity changes is called acceleration. Okay? So we can look at final distance is initial distance plus change in position. Change in position is delta D. So the final distance is the initial distance plus the rate that position changes times time. Now, why do I keep going back to this? Because if we understand this concept, the next concept is going to build right on top of this and parallel it very, very nicely. The final distance is where it was to start with plus how it changed. Okay. Now we're talking about this velocity changing. We're going to talk about this velocity changing. So we want to know, what is the final velocity? The car's at the red light, you hit the gas pedal, some time passes. What's the final velocity? Or maybe you're not at the red light. Maybe you're driving down the road and you come to the speed limit sign. It goes from 35 to 45. So the final velocity is how fast were you going to start with plus how much did velocity change. Okay, so we look at this formula. How far is something from some place? How far was it to start with, and how much did it change? How fast is something going? Well, how fast was it going to start with, and how much did it change? So that's the parallel between final distance and final velocity. You want to know what the original condition was, and how much did that condition change. So when in the distance equation, the final distance, initial distance plus velocity times time. The velocity formula, the final velocity, is equal to how fast was it going to start with plus how much did it change. Well, the rate at which velocity changes is called acceleration. And just like we will say the rate at which position changes times time, the rate at which velocity changes times time. So the final velocity is equal to the initial velocity plus acceleration, the rate at which velocity changes, times time. So delta V, the change in velocity, so just like we had in this case, delta D is velocity times time, the rate that position changes times time. Delta V is equal to the rate at which velocity changes times time. So the final velocity becomes initial velocity plus acceleration times time. So what does this look like in a problem? In a problem, it looks like this. Let's say we have a bike going down the road, and its initial velocity at the beginning of the situation, you just look up and you see a bicycle, and it is going, let's say it's going 5 meters per second. Moving pretty quick. And let's say that it begins to accelerate. So it accelerates at a rate of 2 meters per second. That's going to be the change in velocity every second. Every second, it's going to gain 2 meters per second in its velocity. Okay? So now the question is, after 4 seconds, how fast is it going? And how fast is it going? What that really means is, what's its final velocity? What is v sub f? So when someone says, after some period of time, how fast is it going? What they're really asking is, what is the final velocity? So final velocity is equal to the initial velocity plus the rate that velocity changes, by definition acceleration, times time. And after 4 seconds is going to be our t. So v sub f equals v sub I plus at. Now, we have an equation, we have all of our data. All we have to do now is plug in and solve. Final velocity equals initial velocity plus the rate of acceleration times the elapsed time. Okay? So we have v sub I, 5. We have acceleration, and we also have time. So the 4 becomes down, the 2 comes down, and now all we have to do is calculate. I can do this in my head. 2 times 4 is 8. Initial velocity is 5, so v sub f equals 5 plus the change in velocity is 8. 5 plus 8. I can also do that in my head. 5 plus 8 is 13. So the final velocity is 13 meters per second. Now, I didn't carry the units throughout the entire calculation, but the units will go through. Velocity is in meters per second, acceleration is in meters per second, and time is in seconds, so that the time cancels out. That's another layer of math, but it works out. If you plug the right numbers into the right places, the math works out. This is really not that complicated, and it's not terribly different from what we did here, where we took the initial distance and added it together. It's not terribly complicated. So we start with initial velocity, and then how much does the velocity change is going to give us so that's the concept, and here's the formula. Thank you for watching. I hope this introduction to acceleration is helpful, and that you can use it to develop your skills in motion physics. See you in the next episode.